Alright guys, today's essential question is, how do we simplify rational functions? How do we simplify rational functions? Alright, let's start off by talking about what a rational number is. Well, the most simplest definition for a rational number is simply a fraction. So, for example, 1/3 is a rational number, 4/5 is a rational number, negative 11 over 12 is a rational number, 14 over 20 is a rational number, even 7 is a rational number because you can make this a fraction by simply putting it over 1. Now, the way that we simplify rational numbers, remember that you can only cross out factors. So 4 over 8, if I want to reduce that fraction, I could say that the factors of 4 are 4 times 1, the factors of 8 are 4 times 2, so I can cross out the factors of 4, and that leaves me 1/2. So that's how I can simplify that rational number. 8 over 12, well, 8 is 4 times 2, 12 is 4 times 3, 4 is crossed out, so that leaves me 2 over 3. 14 over 35, well, 14 is 7 times 2, 35 is 7 times 5, the 7 is crossed out, and that leaves me 2 over 5. And that's how you simplify rational numbers. Well, let's apply these ideas to what rational expressions are. Rational expressions are fractions with polynomials. So some examples of rational expressions would be like x plus 3 over x squared minus 9, or 3x plus 6 over x plus 2, or x squared minus 5x plus 6 over x squared plus 7x plus 8. Those are all examples of rational expressions. Some non-examples might be like the square root of x, or x to the negative fifth, or 1 over x, or even x to the 3/2. All those are examples of non-rational expressions. Alright, let's take a look at 3 examples right quick. Let's say I wanted you to simplify 6x squared over 9x. Well, what I would do is I would list out the factors of my numerator and my denominator. So let's talk about the numerator first, 6x squared. Well, factors of 6 are 2 times 3, x squared means x times x, over the denominator. Factors of 9 are 3 times 3 times x. Remember, you can only cross out factors. So since I've factored the numerator and the denominator, the 3's cross out, the x's cross out, that leaves me 2x in the numerator and 3 in the denominator. Alright, for the second example, I have x plus 2 over x squared minus 4. Remember, when we're talking about factoring, 3 big things. Greatest common factor first, then difference of 2 squares, then trinomials. Well, in the numerator, I just have x plus 2. There is no common factor, it's not a dot, and it's not a trinomial, so I can't factor x plus 2 any more than it already is. But in the denominator, I have x squared minus 4. Now, there is no GCF for this, and it's not a trinomial, but x squared minus 4 is a difference of 2 squares, and which means I can factor this into x plus 2 and x minus 2. So I can factor the denominator into x minus 2 and x plus 2. And now I have a common factor of x plus 2, so those can cross out. And if there's nothing left in the numerator, it's understood to be 1. So 1 over x minus 2. And that's my simplified answer. Now notice that in my denominator I have x minus 2. So I need to keep in mind that there's something called an excluded value, or a number that makes the denominator equal to 0. Well, my excluded value for this problem would be x is equal to 2. The reason is because if you plug in 2 for x, 2 minus 2 is 0, and so you get 1 over 0, and that's undefined. You never want a 0 in the denominator of your fraction. So this is what we call an excluded value, or x is equal to 2. That's my excluded value. Alright, for the third example, notice that I do have a trinomial in the numerator, and so I'm going to factor this trinomial into x minus 3 and x plus 1. The reason is because negative 3 times 1 is negative 3, but also negative 3 plus 1 is negative 2. In the denominator, x squared minus 1, I'm going to factor that into x plus 1 and x minus 1. Notice that they have a common factor, x plus 1, so that leaves me x minus 3 over x minus 1. So there's my simplified answer, but I do have an excluded value, and in this case my excluded value would be positive 1, because if you plug in a positive 1 for x, 1 minus 1 is 0. Alright, let's try some more examples. Alright, let's take a look at this first one right here. 3x plus 6, I could factor the numerator, a GCF of 3, that'll leave me x plus 2. In the denominator, I could factor this trinomial into x plus 2 times x plus 1. The reason is because 2 times 1 is 2, and 2 plus 1 is 3. Notice I have a common factor of x plus 2, so that leaves me 3 over x plus 1. Notice that I do have an excluded value. My excluded value would be negative 1, because if I plug in a negative 1 for x, negative 1 plus 1 is 0. Alright, for the next one, if I factor this trinomial in the numerator, I'm going to have x plus 5 and x minus 1. The reason is because 5 times negative 1 is negative 5, and 5 minus 1 is positive 4. The denominator, I can factor that into x minus 3 and x minus 1, because negative 3 times negative 1 is a positive 3, and negative 3 minus 1 is a negative 4. Notice I can eliminate the common factors, and that leaves me x plus 5 over x minus 3, which is my simplified answer, but there is an excluded value. In this case, my excluded value is 3, because if I plug in 3 for x, I'm going to get 0 in the denominator. Alright, look at the next example, example 3. 8, I could factor that into 2 times 4. Negative 2x, I can factor that into negative 1 times 2 times x. The 2's cross out, and that leaves me 4 over negative 1x. And then I do have an excluded value of x is equal to 0, because if I plug in 0 into this, 0 times negative 1 is 0, and I don't want a 0 in the denominator. For the next example, I'm going to leave the x plus 3 alone. I can't factor that any further, but I can factor this trinomial, and I'm going to use x minus 5 and x plus 3. The reason is because negative 5 times 3 is negative 15, and negative 5 plus 3 is negative 2. I can cross out my common factors, leaves me a 1 in the numerator and x minus 5 in the denominator. I do have an excluded value here. My excluded value would be positive 5. Alright, let's keep on going. For the next one, if I look at this example, I can't do anything with the x in the top, but in the denominator I see a GCF of 3x, and then that leaves me x minus 3. I can eliminate the common factor of x, which leaves me a 1 in the numerator, and 3 times x minus 3 in the denominator. I do have an excluded value of x is equal to 3, because if we plug in a 3 into this, 3 minus 3 is 0. Alright, for the next one, if I notice my trinomial in the numerator, I'm going to factor that into x minus 4 and x minus 1, because a negative 4 times a negative 1 is a positive 4, and a negative 4 minus 1 is a negative 5. In the denominator, that's a difference of 2 squares. The square root of 16 is 4, so I'm going to have x plus 4 and x minus 4. Notice I can cross out the common factors. That'll leave me x minus 1 over x plus 4. And I do have an excluded value of x is equal to negative 4, because if I plug in a negative 4 in for x, I'm going to get negative 4 plus 4, which is 0, and that's not good in a denominator. Alright, last one. If I look at the numerator of this one, x squared minus 9, that's a difference of 2 squares, so I can factor that into x plus 3, x minus 3. In the denominator, I can't factor that anymore, but I can cross out the common factors, and that leaves me x minus 3. Notice that there is no excluded value for this one because I don't have a denominator, but anything but 1. Alright, in the second one, I can take out a GCF of 2x, which would leave me x minus 3. I can take out a GCF of 4x, which would leave me x plus 2. I know I can eliminate the common factors of x, so that will leave me 2 times x minus 3 over 4, which I can write as 2 times 2 times x plus 2. So I can cross out another common factor of 2, which will leave me x minus 3 over 2 times x plus 2 as my final answer. And there is an excluded value for this problem. It would be x equals negative 2, because if you plug in a negative 2 into there, you'll get 0 for the denominator. All right, that's it for today's lesson.